Right, I'm cutting 30 teeth on the cannon pinion for the Harrison clock. This is a piece of boxwood, and I set up the blank at the right diameter, and basically what I'm doing is I'm machine cutting the teeth rather than hand cutting them like I did on this wheel. I just like them to be a bit more regular. And that should work out, I think. Right, that's cut all the teeth. The reason I'm using this particular cutter is because first, it's the only one I've got that's anywhere near the right size, and secondly, I was a little worried that the teeth on the first wheel I made would be a little bit weak, being traditional clock form, and this is more of a kind of normal gear tooth form, but the actual teeth form is the same on both, very similar at any rate. I could cut a slot in them and make them a bit longer, but I think that would just be unnecessary. I'll give this a try as it is, I think. So these will be a good deal stronger than this tooth form, and bearing in mind that this is end grain on this surface, so these teeth have not got a huge amount of strength, but boxwood's pretty tough stuff. And I made this a little bit fatter just so that it's got a bit more strength. Should mate alright with the previous gears that I had. See, that mates nicely with that. So that is the same format as this, or very similar, just not cut quite so deep. Okay, that's that job done. I've transferred the blank for the wheel onto the arbor, and I'm just going to change over to put the milling spindle on here. I'm using the Potts milling spindle I bought some time ago, which is an excellent tool. So I take that off. And that goes on where the tool post goes, and I can check that I've got it at the right angle so that it's pointing directly at the front of the lathe. The spindle sits on there. Now I've got an index mark on here, so I know that's parallel. And it's as simple as that. And then I align that to the centre of the lathe. Got a mark that I've put on here. So that is over the top of it. I now lock the cross slide. So I don't inadvertently move anything. Right, that is now sitting on the top of the disc, and I've got to now drop the height of this to allow for the cut, and I'm going to make a 6mm cut. So if I put the dial gauge on underneath here, just take it round, excuse it jerking around a little bit. One, 2, 3, 4, 5 millimeters down. Lock that off. Alright, let's put the power supply for the motor, and this is a brushless motor, which I added extra finning to give it some extra cooling, and that is a very powerful servo motor which hasn't got the control wires connected, and it runs very well. So that's how that works. Now I just put the 42 teeth. And that finishes that. So I take this off and clean up the back of it. Right, now I'm back on the workbench, and there's a blank wheel which I've made up ready with slits for 45 teeth round the edge, 4mm in, and these little teeth are made up from this veneer, and they're 9mm long, these ones. They have to be a reasonably close fit in here, which is 2.15mm, which is roughly what that is. It swells up a little bit when you put the glue on, so they tighten up as you fit them together. And this is 9mm line from the edge, and then the first job to do is to put the tooth end profile on the edge using the permagrit block, which is nice and flat, and you sand along here and sand along there. So I'll put that on next, and then when I've done that I'll cut that off, mark here for the size of these, and I found the quickest way to do them is not to saw them off, but to cut them off with a Stanley knife. And then they're quite quick to do. So I'll set a rounder profile off, doesn't take very long. Right, I've rounded the profile on. This particular one is more of a normal tooth profile. It's not a round at all. So it's like a normal tooth. So a bit like the teeth that I have here. So the next job is to saw this off along this line, and then cut the individual teeth off. Right, now marked on here 6mm apart, all the lines for the teeth, and then it's a fairly simple matter of just cutting these off. And now those are the individual teeth which go into the wheel nice and snugly. The only thing I haven't done yet is trim them to length, and they will be slightly oversized. Yeah, 9.27, so I just rub them down on the permagrit. Say a bit time consuming, but there we are on 9.08. It's quite easy to keep reasonably good control. .98, so that's fine. So I just carry on doing that until all these are cut, filed to length. It might just be worth mentioning, this is one of the larger wheels with the larger teeth on, and they go further into the wheel to secure it. And this is a ply sheet of oak 3-ply. When the wheels are finished, they're faced off so that it becomes 5-ply, and on the smaller wheels I turn the facing down so it's not quite so thick, and that's one that I've turned down slightly because that's one of the motion work wheels. And then the very large wheels, like the great wheel, that is 2 sheets of ply glued together. This isn't the same method that Harrison used. Harrison split his up into segments, and he glued the segments together with a laminated sheet on each side so that he ended up with more or less end grain, but this is a lot better because you've got pure end grain only, and also the plywood sheets are pretty stable, so once these are let into here and faced off, they aren't going to move very much, and I know that from the other clock that I've made, which is a wooden clock. The other clock had quite large teeth because they faced in this direction and there were staggered rows of 2, and that meant that each tooth was made up of 1 wedge, and that was an awful lot of wedges to glue together, and it's actually quite difficult to get them to centre when you do that. And Harrison's method is also quite difficult, and I feel that my current method is much the easiest to do. So all I need to do now is make all the rest of these. I've now finished making all of these teeth. They're all the right length and the right size, and the profile's reasonably good. So what I do is I glue all these in first, and when the glue's gone off I rub the side down so that it looks like this, and then I put this in the lathe and just take the tips off, so if any of them are sticking up a bit further than others, then they can be levelled off. I think it's called in horological terms topping the wheels. The glue that I'm using for this job is aliphatic resin, because you can sand it, and it does take hold of the material very quickly. It sets up, and I've used it for model aeroplanes and things, and it seems to work very well, so I'm happy to use that. Right, so now we can start to glue these in. A long job this is, but quite satisfying. So we do these one at a time. Oops. Little glue on each side, little glue on the bottom, glue in the slot, press that in and just check that it's at 90 degrees. Take away the excess glue on the side, excess glue there. You don't want that sitting around, you can't get rid of it very easily. Do another one. Getting close to the end now, 2 to do. Right, this is the next day, and there are all the teeth glued in. I've got my perma-grit block on the smooth side. There's a rough side and a smooth side. I always use the smooth side for this sort of work. Just rub it up like this. And that's the other side sanded off. And now I need to mount this in the lathe and just take the tips off just to reform them and check that there's not one that's sticking out too much. I've mounted this now in the lathe, and I'm now in a position of just checking first of all is it running nice and true. That looks pretty good. And I'll just take the tips off and then check each tooth separately. Hear a slight knocking, so it's taking one of the longer teeth off. And I don't suppose I'm going to be able to show this, but that tooth there has got a flat across the top of it, and some of the others that's got a flat across the top. Some of the others are pretty much untouched, so I think I'll just take a touch more. Doesn't need any more than that. So the next job is to just file them individually to correct the tooth form, and again I use a perma-grit. This is a perma-grit angle, and it has a fine end there, and that's proved to be just the job for this. Right, that's now finished, and all those teeth are nicely shaped, and I can now check the depthing. So that's the meshing between this gear and the gear it mates with, and I do that on what's called a depthing tool.